Every year, Americans throw away 290 million tires. That's almost one tire per person. And here's the problem. A single tire can take up to 1,000 years to decompose. But what if I told you those old tires aren't trash? They're the secret ingredient, making America's highways stronger, quieter, and longer lasting than ever before. Today, we're going inside the facilities that turn your worn-out tires into the asphalt you drive on every single day. This story starts with a crisis. Back in the 1980s, America had a massive tire problem. Illegal tire dumps stretched for miles across rural landscapes. And then came the fires. In 1983, a tire dump in Winchester, Virginia, caught fire and burned for 9 months straight. 7 million tires. The smoke was visible from space. That disaster changed everything. The EPA cracked down hard. States scrambled for solutions. And engineers discovered something incredible. Ground-up tires could actually improve asphalt. Not just dispose of waste, but make roads better. By the early 1990s, states like Arizona and California started testing what they called rubberized asphalt. The results shocked everyone. Today, over 20 U.S. states use tire-modified asphalt on their highways, and the process starts at recycling facilities scattered across the country. Let's follow a tire's journey. It begins at collection centers, where old tires arrive by the truckload. These aren't just worn-out passenger car tires. We're talking massive commercial truck tires weighing over 100 pounds each. Tractor tires, even aircraft tires from places like Phoenix Sky Harbor International. First stop is inspection. Workers check each tire because not everything can be recycled. Tires contaminated with oil, hazardous chemicals, or excessive metal damage get separated. But here's something most people don't know. About 30% of collected tires are actually good enough for retreading, which means they never enter the recycling stream at all. The rest move to the shredder, and this is where it gets wild. Industrial tire shredders are absolute monsters. We're talking machines with hydraulic arms generating over 100 tons of crushing force. The first pass uses rotating knives with tungsten carbide cutting edges that slice through steel-belted radials like paper. Each blade costs over $5,000 and needs replacement every few months because tire steel is incredibly tough. The shredder reduces whole tires into rough chunks about 12 inches across. These chunks ride conveyor belts through a magnetic separator that pulls out steel wire. Modern facilities recover over 99% of the steel, which gets sold to steel mills. Nothing goes to waste. Next comes the granulator, a secondary shredder with smaller, more precise blades. This machine grinds the rubber chunks down to pieces about 2 inches across. At this stage, the material looks like black gravel. But we need to go much finer for asphalt. Enter the cracker mill. The cracker mill is the heart of the operation. Inside, heavy steel rollers spinning at different speeds literally crack the rubber particles apart at the molecular level. Temperature control is critical here. The friction generates heat, and if it gets above 200 degrees Fahrenheit, the rubber starts degrading and loses the properties that make it valuable for asphalt. The rubber passes through the cracker mill multiple times, getting finer with each pass. Pneumatic screening systems separate particles by size using vibrating mesh screens, with openings measured in fractions of an inch. The material that passes through is called crumb rubber. Different asphalt applications need different rubber sizes. Highway surface asphalt uses fine crumb rubber, passing through a 30 mesh screen, which means particles smaller than 0.6 millimeters. Base layer asphalt can use coarser 10 mesh material. Here's something incredible. One facility in California processes over 12 million tires per year. That's one tire every 2.6 seconds, 24/7. The crumb rubber they produce would fill an Olympic swimming pool every single week. Meanwhile, parallel lines handle the steel wire and fabric recovered earlier. The steel gets compacted into dense cubes, weighing up to 2,000 pounds each. Steel recyclers love this material because it's high-quality wire with minimal contamination. The textile fiber, mostly polyester and nylon from tire casing, goes to cement kilns where it burns as supplemental fuel. These fibers have a heat value comparable to coal, but burn cleaner. Now the crumb rubber is ready for asphalt production. But first, quality control runs extensive tests. Laboratory technicians analyze particle size distribution using laser diffraction equipment accurate to 0.1 micrometers. They test for contamination, moisture content below 0.5%, and verify the rubber meets ASTM D6270 specifications, the American standard for ground tire rubber. Any batch that fails gets reprocessed. There's zero tolerance for error, because this rubber is going into highways where safety is paramount. From the recycling facility, crumb rubber ships to asphalt plants in specialized trucks with pneumatic unloading systems. A typical asphalt plant might receive 50 tons of crumb rubber per day during paving season. At the asphalt plant, the magic happens. Traditional asphalt is simple. Aggregate stone, sand, and petroleum-based liquid asphalt cement heated to around 300 degrees Fahrenheit and mixed together. Adding crumb rubber changes the chemistry entirely. There are two main methods. The wet process mixes crumb rubber directly into the liquid asphalt cement before adding aggregate. The rubber particles partially dissolve, creating what engineers call a modified binder. Plants heat this mixture to 375 to 400 degrees Fahrenheit and hold it there for 45 minutes to an hour. During this reaction time, the rubber swells and absorbs light oil fractions from the asphalt cement. The result is a thicker, more elastic binding material. When you add aggregate and finish the mix, you get asphalt that's fundamentally different from regular pavement. The dry process takes a different approach. Crumb rubber gets added directly to the aggregate during mixing, replacing some of the fine aggregate particles. This is faster and simpler, but produces slightly different performance characteristics. Most major highway projects use the wet process because the performance gains are substantial. And here's where it gets really interesting. Rubberized asphalt isn't just recycling. It's actually superior to regular asphalt in almost every measurable way. Studies by the California Department of Transportation, Caltrans, found rubberized asphalt lasts 40 to 85% longer than conventional pavement. That means a road that normally needs repaving every 10 years can now last 18 years. The rubber makes the pavement more flexible, so it handles temperature swings better. In Phoenix, where summer pavement temperatures hit 160 degrees Fahrenheit, regular asphalt cracks and develops ruts. Rubberized asphalt stays flexible and resists deformation. But here's the crazy part. It's also significantly quieter. The rubber particles create a slightly more porous surface that absorbs sound waves. Tests on Interstate 10 in Phoenix showed noise reduction of 3 to 6 decibels compared to regular asphalt. That might not sound like much, but a 3 decibel reduction means 50% less perceived noise to the human ear. Residents living near highways paved with rubberized asphalt report drastically reduced traffic noise. Some cities specifically request it for roads near residential areas. Installation follows strict protocols. Paving crews use the same equipment as regular asphalt, but temperatures and timing are more critical. The rubberized mix must be laid at 325 to 350 degrees Fahrenheit. Too cold, and it won't compact properly. Too hot, and you risk damaging the rubber polymers. Rollers compact the fresh pavement in multiple passes, first with a heavy steel roller, then pneumatic tire rollers for final smoothing. The rubber helps the pavement compact more uniformly and reduces the segregation problems that plague regular asphalt. Within hours, the pavement is cool enough for traffic, and the environmental impact is substantial. Every mile of two-lane highway paved with rubberized asphalt uses approximately 2,000 to 3,000 tires. A major interstate project can consume hundreds of thousands of tires in a single season. Arizona alone has diverted over 140 million tires from landfills since starting their rubberized asphalt program in the 1990s. And remember those tire fires from the 80s? They're essentially extinct now in the United States. Modern regulations require proper storage, and the recycling infrastructure has created economic value for old tires. What was once worthless trash now sells for 40 to 80 cents per pound as crumb rubber. The economics work because rubberized asphalt's longer lifespan offsets higher material costs. Initial construction might cost 10 to 15% more than regular asphalt, but the extended service life and reduced maintenance deliver net savings of 20 to 30% over the pavement's lifetime. Innovation continues pushing boundaries. Researchers at Texas A&M University are experimenting with rubberized asphalt, modified with bio-oils from plants, reducing petroleum dependence even further. Others are developing ultra-thin rubberized overlays that can be applied to existing roads, extending their life without complete reconstruction. Some companies are producing rubberized asphalt shingles for roofing, athletic tracks, and playground surfaces. The same crumb rubber technology that fixes highways is making playgrounds safer and running tracks faster. From disaster to innovation. From waste to infrastructure. America's old tires aren't ending up in landfills anymore. They're being transformed into the roads that carry us home. So, next time you're driving down a smooth, quiet highway, remember, you might be rolling on the same tires your parents threw away 30 years ago. Recycled, reimagined, and literally paving the way forward. From worn-out rubber to roads that last. Thanks for watching. Hit that like button and subscribe for more fascinating looks at how we turn yesterday's waste into tomorrow's infrastructure. See you next time.